Now that we have set up our database in our last episode, we can go ahead and start querying our database from our Go app. These are some of the well-known database libraries in Go, and given a layered architecture, these database libraries are going to allow us to interact with the database at the store layer as shown in the diagram. And among these database libraries, we're going to use sqlx to query our database in this episode. And sqlx is just a standard Go SQL library with a set of extensions. So for the standard SQL package, there are some of the commonly used methods for each of the queries. And sqlx provides its own set of methods that helps us query database more easily. So instead of query row or exec, we can use named exec. And instead of query, we can use select or get context as provided by sqlx. And here's just an example of a comparison between the two. So with the standard SQL package, we have the exec context method that has an insert query with values and the question mark placeholders. So for exec context or exec, you have to refer to the fields positionally using those question mark placeholders. But sqlx provides this named exec context that binds the field names to the field of the struct using the DB tags. And here's just another example. For the standard SQL package, you call query or query context that returns an array of rows, which you have to iterate over and scan each row at a time. With the sqlx package, you have the select context that inserts the values from the select query into the products array. So now that we have looked at how sqlx is different from the standard SQL package, we can move on to the implementation. We can start off from where we left off in the last episode, where we defined our migration files. Before we start with anything, we first want to create our Go mod by saying go mod init followed by the name of your repo. And in case you're new to Go, the Go mod file is what allows us to keep track of our dependencies. And once we have the Go mod file, inside the DB directory, I'm going to create a file called db.go. I'm going to say package db, and here I'm going to define a struct called database. And this will have a database of type sqlx.db. And if I try to save this, VS Code will try to import this package, but I don't have this package in my module yet, so all I have to do is actually go mod tidy here. And this is going to find the module and download it for you. And then down here, I'm going to create a function called new database that will return a pointer to this database struct. And here I can do sqlx.open, and this takes in a driver name and a data source name. So we have our MySQL database driver, and this has a root password as our password, and inside this TCP bracket, our MySQL is running on localhost 3306, and that will be followed by the name of our database. And I just want to add this parameter where parse time equals to true, and this returns the database as well as an error. And if there is an error, we can say return nil and say here something like error opening the database. Save that real quick, and if there's no error, I can just return this database struct. And I'm going to add two more methods here to close the database and also to get the database, and this will return our private database variable defined inside the database struct. And just to give you a full picture on where this new database function will be called from, I'll create a directory cmd and ecom API, which is the name of our microservice, and our main.go file. So this main.go file is the entry point for the Go app, and here we have a function called main, and this is where we'll be calling db.newDatabase. So this db is referring to this package db here, and VS Code is going to know where we're trying to call this from. And this returns our db struct as well as an error. And if there is an error, we can panic, or we can do log fatal saying error opening the database. And then we can make a deferred call to close this database. And if there's no error, we can say successfully connected to database. And right now we're not doing anything with the database yet, but later we're going to define our store method here by calling store.new MySQL store and pass in our database as an argument. And this is actually what we are going to implement next. From the root of our project, I'm going to create a directory called ecom API, and inside there a store directory. And then I'm going to create this file called store.mysql.go. I'm going to define this package store and have a struct called MySQL store. And it's going to have a DB of sqlx.db type. And it will also have a constructor that accepts a DB as an argument and returns a pointer to this struct. So this is actually where we're going to define all the methods to query our database. So down here, we're going to have something like MySQL store and a call to create product. And this will accept a context as well as a pointer to our product struct, which we haven't defined yet. So inside this store directory, I'm going to create a file called types.go. So this will be package store, and I already have this product struct definition prepared to save us some time. And there are just a few things to note here. We have the JSON tag as well as a DB tag, and we need this JSON tag so that we can marshal the request body into the struct later on. And we need this DB tags to map each of the fields to the fields of the database queries. And this updated at field has a pointer type because this field is nullable. And now that we have defined our product struct, we can come back here and say this method returns a pointer to our product struct as well as an error. So inside this method, we can use the sqlx DB and call named exec context, where we pass in the context and the insert query like this. So this is a query suggested by Copilot. So let's have a look and see if this is accurate. So we are inserting into the products table the name, image, category, description, rating, number reviews, price, count in stock. And we have these mappings, which are the field names of this product struct here. And this product struct is what we have in this argument here. So that looks good, and named exec context returns a SQL result and an error. So we can do result error. And if there is an error, we are going to return nil or an error saying something like error inserting product. And SQL result gives us this last insert ID, and we can check if there is an error here. And again, return an error if there is. And then I'm going to assign this ID to the product ID field here, and then return our product struct. In case this is not obvious to you, we're getting the last insert ID because this ID is auto-generated from the database, and we are not manually inserting the ID into the products table. So we are going to get the last insert ID and manually assign that ID to the ID field of this product. And now that we're done with the create product, let's move on to our get product. And the rest of the methods will be pretty similar. The suggestion mostly looks good, so I'm going to take this suggestion. There's just one thing I want to change here. I know this is something minor, but I'm going to get rid of this spacing there. And then I'm going to move on to the list products. So this will be pretty much the same. It's using the select context, and we define our array of products, and we just have to put this products as the second argument here. And the result from this select query is going to be assigned to this array of products here. So I'm going to save that, and moving on to the update product. Again, this gives us a suggestion. So we call named exec context update products, set the name, image, category, description, and so on. And this looks mostly good as well. And lastly, we have a delete product, and this one is pretty simple. It's just an exec context call with a delete query where ID equals to the ID passed in as an argument. So that's actually all we have for the implementation, but ideally we want to test this as we go. So when we want to write unit tests, a good practice is to define a test file in the same directory, and it will follow this naming convention where it has a test at the end of the name. And I'm going to define our package store. And the test also has this naming convention where function name starts with the test, and then we say the name of the method, and that has an argument that takes in a testing.t object. So in our test, we can connect to a real database, or you can mock database calls using this package called sqlmock. So this is the GitHub page of the Go sqlmock, and sqlmock provides us with this expect calls to mock our database queries. So in order to use sqlmock, we have to call sqlmock.new. And if I save this, again, we have this red squiggly line, so we can open the terminal and run go mod tidy. Close the terminal, save this file, and this is going to return a mock database, a mock object, as well as an error. But we have to pass an argument into this new method, a sqlmock.queryMatcher option, and queryMatcher equal. So what queryMatcher does is do a match of the expected and the actual SQL strings without white space. So to make better sense of that, we can come back to the README of the sqlmock GitHub page. So there's a section on customizing SQL query matching, and here it says that default query matcher is the regular expression query matcher. And this regular expression query matcher is not compatible with MySQL queries, and for MySQL queries we have to use this query matcher equal, which will do a full case sensitive match. I'm first going to check if there is an error, and if there is, I can do t.fatal saying error creating the mock database, and I'm going to have a defer call to close the mock database. And one thing you're going to realize is that the mockDB is of type sql.db, but our new MySQL store doesn't accept a sql.db, but instead it takes in a sqlx.db. So we have to actually call sqlx.newDB and pass in this mockDB with a name, and this returns a DB, and we'll actually pass this new DB into the new MySQL store. I'm not going to call this MS, I'm going to call this ST and save this. So the first thing I want to do is create this product struct, and I'm going to say the name is test product, test image, test category, and so on. And then we can use our mock object to mock our database call. So we're going to call expect exec, and here we're going to create our query. So it will be insert into products, where we insert image and so on. So we have the name, image, category, description, and so on, as well as the values. And we call will return result and pass the sqlmock.newResult as its argument. With the new result, we define our last insert ID as well as the rows affected. So what we are saying is that we expect our mockDB to call this query here, and that it will return a SQL result with a last insert ID 1 and the rows affected being 1. So with this mock object defined, we can call this createProduct on our store, where we pass the context background and the product struct. This returns a product which will leave empty for the time being, and we'll just check for the error. And if there's an error, we're gonna do t.fatal. And in case this doesn't make a whole lot of sense for some of you, let me go over this concept real quick again. So because our store method takes in a mockDB as its database, and this mockDB is actually associated with this mock object, which we can call expectExec on, and we can define or simulate what this mock is going to exec and also return for us. So we're only testing for the success case right now, but we're also going to add cases for the errors in the later part of the video. And actually, before we move on, instead of checking for error like this, I want to use this package require.noError like that. And this will actually import a package called stretcher testify for us. So again, we have to come here and do go mod tidy. Save this file again. And now we are going to say this returns a product, a created product, and we can check that the ID of this created product equals to 1. And there's one more thing I want to call here, which is mock.expectations were met, and this returns an error, and I want to make sure there's no error here as well. So this just makes sure that our expectations were met in order, and it's not very significant in our test case right now, but I think it's a good practice to include them in our tests. I'm going to save that, and now that we have defined our test, let's go ahead and run this test. So that says okay, everything is working as expected. Now we can move on to the next test, which is TestGetProduct. So there is some suggestion from Copilot, but I'm gonna get rid of this part here because copilots are not always accurate. And here I want to say sqlmock.newRows, and here we define our columns for our rows. So let's see what the suggestion says. That looks good. So with this new rows, I can add row, and here instead of just passing in some string, I'm actually going to copy this product struct here, paste it here, and pass in each of the field from there. So instead of what's suggested here, I'm going to pass in p.created at and p.updated at. And this returns a rows variable, which is of type sqlmock.rows, which then we can pass into the next method we're going to define here. So we're going to call expectQuery here, and we have a select statement from products where ID equals to question mark with args1, which is our ID, and we expect this return the row that we just defined up here. So now that we have our expect query defined there, we can call getProduct on our store, where we get the product with ID equals to 1, and this returns our getProduct, which I will call it GP, and I want this error checking as well as checking that the ID equals to 1. And then just like before, I'm going to say mock expectations were met and require no error. Let's save this and see what this gives us. So again, that looks good. So we can move on to the next test. But by now, you might have noticed that we are actually defining a mockDB and creating our DB with every test we have. So instead of calling this part again and again, I want to create a wrapper function called withTestDB that accepts a testing.t as well as a callback function that accepts a sqlx DB as well as a sqlmock. So this actually does the job for us. So what we are doing here is really the same thing we've been doing, where we create a mockDB and create our sqlx DB, and we're passing this DB and our mock object into a callback function that we defined up here. So what that means now is that within each of the tests, instead of actually defining this part here again and again, I'm going to delete this, and we can call withTestDB and pass in our t, and here we're going to have a callback function that accepts a DB of type sqlxDB and a mock like that. And then ignore that suggestion, and I'm just going to copy what we already have here inside this function here and save that. So this part is our callback function, and this is the part that will be called here inside the withTestDB function. And the same applies to the TestGetProduct. I'm gonna get rid of this part here, just paste that here and copy this entire thing into this function here and save that. And as I briefly mentioned earlier, we're only testing for the success cases right now. So for the get product and the create product, we're only checking when there is no error with our calls. And what we usually want to do to have 100% test coverage is to write tests for all the error cases. So for example, when we're looking at the create product call, we can have errors here when named exact context returns an error, as well as here when the last insert ID returns an error. So when we actually do cd into this ecom API store and run go test with the cover flag, it's going to tell us our coverage. So as you can see, we're only covering the 40.7% of the statements and not 100%. So something we can do in our test is to consider all the test cases. So up here, I'm actually gonna move this product variable to up here, and then I'm gonna define this variable called test cases. And this is going to be an array of struct that has a name of the test case as well as a test. And this test is going to receive a testing.t, and it will also receive a MySQL store as well as our mock object. I should actually get rid of this variable names here, and then inside the structs I'm gonna have different test cases. The first, we have the success test case, and under the success test case we will actually have what we defined down here. I'm gonna copy this into our success test case, and then when we have other test cases, we can add more test cases here like this. And then what we can do is loop through each of the test cases, and as the copilot suggests, we move this logic inside the t.run, and we pass in the name of our test case which is the success test case, and we have a function which is just what the t.run accepts as an argument, and with this t that's passed in, we can call this withTestDB, and the same thing we were doing earlier. So using this DB, we define a new store, and then we pass this store into our test case.test, which is defined up here. With this kind of structure, we don't have to repeatedly instantiate a database and so on, and we can just leave this part as is, and whenever we have a new test case that we want to test for, we can add a new test case here. So we can add a test case for failure to insert a product, and it will have a similar structure. And let's see what the Copilot suggests us. So we have an expect exec call here, and we have an expect exec call that will return us an error saying that error inserting product. So when we call create product, we actually expect there to be an error. So that looks good. And then we just need another test case for failed getting the last insert ID. And let's see what the Copilot suggests us again. So it says we'll return a result saying that error getting the last insert ID. So we need to add a comma here, save that, and let's run this test to see if it's working. So I'm gonna run this test, and it says okay. So looking good, we can now move on to testing the get product. So pretty much the same. I'm gonna move this product struct to here, and I'm gonna define my test cases, which is an array of struct with the name and the test function. And inside here, we're gonna have a success case and a test where we will have this exact thing pasted as the success case for the test. And then we're going to iterate over these test cases and do a t.run and move this thing inside here, called tc.test, close this and the loop. And for the get product call, we only have a single error case where there's an error trying to get context. So I'm just gonna add an error case failed getting product, and the test will look something like this. So this expect query will return an error saying the error getting product. I'm gonna come up here and try to run this test as well. So everything's working. And now you should be seeing some pattern writing the unit tests for these SQL queries. So to save us some time, I'm just going to paste the test that I have already prepared and go over some of these tests to make sure we are on the same page. So we have this test to list of products. It's pretty much the same as getting the product. And here we are only checking for the length of the products, since we are only expecting one row to be returned. But of course you can test for multiple rows, and the same here, we just test for failure to query the products. And for testing the update product, which I didn't name properly here, we actually have a product as well as a new product struct. And then what we can try to do is make a call to create a product and then another call to update a product with this new product struct. And this returns an updated product, and we should expect the new product name to be equal to the updated product name, which is called the new test product. So this is something that's a little bit different for the update case. And we have a test case for failures. And it's pretty simple for the DeleteProduct test, where we just test for the success and a failure. So that's pretty much it. I'm gonna save this file. Then I can come to the terminal here and run go test for both with the cover flag. And now you're gonna see all the tests passed with 100% coverage, meaning we cover all the success and error cases in our methods. So that is all I have for this video. I hope you guys found this helpful. Thank you all for watching.